who can tell me the three shapes we've talked about so far when we're talking about area and perimeter? Griffin. Well, technically four. Go ahead and say those. All right. Circle and triangle. Okay. All right. Now, we've got area and perimeter. I would copy these down. Okay? Because we're going to be having a test in a day or two, so this will be a good little review just to mentally go over stuff, okay? Now, square and rectangle can kind of be combined together using the same formulas. Okay? Who can tell me the formula for area finding a square or rectangle? Want somebody different than Griffin? Okay, you can use base times height, or typically we see it as what? Length times width. Now that's typically how we see that. But you can use the words base and height. Okay? Who can tell me how to find the perimeter of a rectangle? Not count, but add all sides. Okay? Now, there's a formula also when we talk about a rectangle. What is that? Okay. So 2 times the sum of length plus width. That tells me that the length and width have to be added together first before I times it by 2. Okay? You may have a question on the rectangle. Now, why would I say square and rectangle can be used at the same way? They're both four-sided figures, but a square, what am I going to notice when I do my length and width? They're going to be the same. So if the length was 2 on a square, the width is also going to be 2. Okay, but you can still use the same formula. Okay? Now, I'm going to skip over and do our triangle because we still use the word area and perimeter. Who can tell me the area formula for a triangle? Griffin's on the ball. Go ahead, Griffin. Yes. And that's a B. I'm kind of over here to the side, so I want to make him a little bit bigger. Now, help me out on a triangle, though. When I say base and height, what do I know about the base and height within that triangle? They have to make a what? What is that? What is this? What letter? A T. They have to make a perpendicular, which tells me what kind of an angle is going to be right here. A right angle is going to be there, okay? So sometimes you got some funny looking triangles, like on the board over there, that those angles don't make a 90 degree. So they might draw out those little dotted lines to tell you what the height and the base are, okay? So they have to be a 90 degree. So that's correct. What's the perimeter of a triangle? How do you find it? Add what? Add all sides. Now, is there a formula for this one? Is there a formula? No. Okay. There's no formula for that one. Now, when we get into circle, we still have a formula for area. What is that? Pi r squared. And what's the circumference formula for a circle? So this one has 2 formulas. And that's only because of the measurement that's in your circle, whether it's a diameter or a radius, okay? Now, circumference and perimeter both measure the outside of the object, whereas area measures the inside of the object. Okay? Brian? Okay, that's pi. Yes, sir. Yes. So you have to do that exponent before you multiply. Okay? Good question. All right. Anybody have any trouble with the formulas? Okay. All right. Today, we're going to talk about volume. Now, what do you think about, do you think of a solid or a liquid when I mention volume? Liquid, liquid. How much drink did you drink today? How much lemonade is in that bottle? How much water is in that bottle? How much water can be filled in that swimming pool out there? Okay? So it doesn't necessarily mean I have to drink it, but it's measuring how much something can hold. Okay? So volume is going to be a three-dimensional figure. Okay? I could pour water on this table, okay, and it's going to stay, but only because until it gets close to the edge, then what is it going to do? It's going to fall off, okay, because there's no boundaries. So volume has to have something on the sides to hold it in. Could you imagine trying to fill that water bottle if it didn't go up any? Could it hold that much water if there was no sides? Okay, so volume has to have three different things. Now, typically, we have a length, a width, and a height. And all you're going to do here is you're going to multiply all three of those. So if they ask you what is the volume of a rectangular prism, what they mean is that you have a three-dimensional figure. Okay? I'll show you how to draw it in a minute, okay? If I want it to fill that with water, okay? I'm picturing this is the bottom. Okay? These are the sides. This square right here's a side. This square over here's a side. There's one in the back. And then here's the top piece. Okay? So it would be, if this book was empty, if it was hollowed out. Okay? And I'm going to pour water inside this book. Okay? There's no middle inside here. I want to pour it in. I want to find the volume of how much this could hold. Okay? So you're just going to take the length and multiply it by the width and the height. Now, most of the time, what you're going to get when you see an object like this, they'll have something like 6, 7, 4. Okay? Now, we're going to say centimeters here, okay? So is all you're going to do, and I don't care what you are calling your length, what your width, and what your height, okay? Because they're all interchangeable using a commutative property. So I'm just going to multiply your 6 centimeters times my 7 centimeters times my 4 centimeters. Yeah. So on your calculators, what is 6 times 7 times 4? What? 168. Now, who thinks they can tell me the correct unit of measurement? How many centimeters did I multiply together? Units cubed. So this is going to be centimeters cubed. Because I have 3 centimeters that I'm multiplying together. So centimeters times centimeters times centimeters means how many times am I multiplying centimeters? 3 times. So that means cubed. Okay? So area dealt with a square unit. Volume deals with a cubic unit. Okay? And cubic is spelled C-U-B-I-C. And if you don't have a unit, like I gave you centimeters, okay, you would put cubic centimeters, which is that, or you could spell it out, cubic centimeters. If there was no centimeters, you could write cubic units. Okay? So let's do one together. All right, I'm going to show you how to draw this. Okay? Doesn't matter what you have. If you want to draw a rectangle, put one rectangle down. I'm going to try and show you how to do it. And it takes practice, because sometimes I draw them and I couldn't see it, okay? Now, about halfway in the middle of this box, okay, is where I'm going to stop at. So I'm going to go right up here, and I'm going to come down with another triangle. See how I make about the same size triangle? I just kind of scooting him over and up. I mean, a rectangle, I'm sorry. Rectangle. Did everybody see what I did? Okay, now I'm just going to connect corner to corner. What? Well, if I connect it correctly, it'd be corner to corner. Now, sometimes people on this one will draw that dotted line. Sometimes they'll draw it, sometimes they'll draw like dotted lines in here to show you front and back. Yeah. Y'all see how I did it? Now, you can draw anything like that. You can do a triangle like that. Okay, a circle. Okay. Now, let's say this was, all right, let's get back on track. Let's say this was 7 inches. This was 9 inches. No. And this is 4 inches. I want you to find the volume of this rectangular prism. So I want you to find the volume. Actually, I'll write up top so y'all can see. I want you to start with the formula. Just so we learn it, start with the formula, substitute it in, then use your calculator to give me an answer. So you should have 3 lines. I know y'all hate me for doing it, but you got to learn it. Length times width times height. Substitute your numbers in for length, width, and height. All right, Rachel. Tell me what I'm going to write on the first line. Okay. What's on my second line? Okay, I'm going to squeeze inches in over here. All right, and what's my answer? Oh, sorry. 252 inches cubed. I mean 2 extra lines. I want the formula. I want you substituting in, and I want the answer. Volume is really easy, especially rectangular prism. Now, when you get into a volume of a triangle, okay, there's formulas, okay, and the good thing is once you have the formula and you just do the math, it's okay. All right, that's like filling this cylinder, okay? It has a different volume than this basket. Would you agree? Okay, so they have different formulas because they're different shapes. The only one you learned this year is a rectangular prism. The others will come next year, okay? And you'll learn those as well. All right, so what you're going to do right now, we have one more thing after a while to do, so I'm just going to... All right, the next thing we're going to talk about today is called surface area. Now, we know what area is. Area is what? The amount inside of an object, right? Now, surface area, okay? If we pretend there's a lid to this, okay? So it looks like a box, Christmas box. Christmas is a good time to talk about surface area, okay? Because what do parents do to those Christmas boxes? They wrap it, okay? Now, when we wrap Christmas presents, we actually cover more than we need to because we overlap things, right, and tape it. If I'm talking about the surface area of this basket, okay, that says I just want to cover exactly edge to edge. So I want to cover the area of this square, the area of this one, area of this one, area of this one, the area of the bottom, and the area of the top. So I don't want any pieces overlapping. Okay, so it's just a little different than Christmas presents because we do overlap. All right, parents are going to sit down and make it exact corner to corner. Okay, but when they talk about surface area, that's what they are asking, exact. Now, how do you find the area of this rectangle or square right here? Length times width. How do you find this one? And this one? And this one? Okay, and the bottom and the top, right? Now, let me ask a question. How does this one change? It's a rectangle, but how do I find the area of this side? Well, length times width or base times height. Length times width. Length times width. Length times width. So you're still doing the same thing. Well, you're going to cover all sides. Okay? Now, how many sides did this one have? And this is called faces. When you talk about a three-dimensional, what you're seeing, this is called a face. So, how many sides? Okay? If you have a four-sided figure on the bottom and the top, you're going to have 6 faces. Okay? So, it doesn't matter. This one has how many faces? 6. Because pretend we pretend that we have a top, okay? How many faces does, if this was a box, how many faces would it have? 6. Okay? So a rectangular object or a cube, square, is going to have 6 faces. Now, here's your formula for surface area of a rectangular prism. Oh, I forgot my U. Okay? And remember, my rectangular prism looked like that thing we drew a minute ago. If you want to, it's up to you. I'm not drawing a very straight line, so sorry, but okay. Now, again, they may give you sides. Okay, they may give you numbers, and they'll give you the 3 numbers for the height, the length, and the width. Okay? I'm just going to actually put length, width, and height. Those will be replaced with numbers in a minute, okay? I'm going to go right above mine and write my formula. Surface area is usually spelled with the words SA, which stands for surface area. Okay? My formula for that is 2 times length times width. Now, if I look at this object and I look at the length and the width, would you agree that that's covering this bottom piece of this rectangle right here? Okay. Do I have another piece of that rectangle that looks the same size? Which would be this top piece right here, right? So how many of those do I have? 2 of them. That's why I put a 2 times the length times width. Because there's going to be 2. There's the bottom and the top, correct? It does kind of look like it's curving, doesn't it? Okay? Alright, but everybody understands why I said 2 times the length times the width, right? I'm gonna go back and delete those because we're going to talk about another side here. Plus 2 times width times height. And now you can put those in parentheses if you want to. It doesn't matter. Width times height. Here's the height and here's the width. So here's this square. So he looks like I'm looking at this side of the box. And do I have another one of those? Where? On the opposite side. So he looks like I've got this. And how many of those do I have? I have 2 sides, right? Of the same measurement. That's why it's 2 times that. Okay? Plus, actually I need to go back. Oh no! There he goes. Okay. I lost him totally. Now, let's pay attention. Look at the combinations here. L and W got grouped together. W and H got grouped together. Which 2 hasn't been grouped together yet? L and H. Now, where's my L and H? Well, here's my L, and what was this representing? H. So this one was an H as well. So I'm looking at this piece here, which is this front of this box, and where's there another one? He's kind of in the back of the box, so he's back here. And how many of those did I have? I have 2 of those. Hence, 2 times length and width. Okay? Okay? Makes sense, right? It's kind of hard for me to show you on this because all my sides are the same. Okay? But look at my book. Now pretend it's all solid, okay? Where's the other piece that measures the same exact piece of this? On the other side, right? What about this side? That side. What about the top? Okay, so there's 2 of each one. Okay? Now sometimes when you get something like this, they may all end up being the same measurement. Okay? So that one might look a little different than your other rectangular prism. Now, I'm going to jump ahead. You're good to keep following where you're at. I'm going to draw us another little rectangular prism. Let's say this is 4 centimeters, this is 3 centimeters, and this is 5 centimeters. Okay? First thing you're going to do is you're going to copy your formula. 2 length times width plus 2 width times height plus 2 length times height. It is, okay? If you didn't know, sheet of paper, get it. Okay? Here's what I would suggest. I don't care what your length, your width, and your height is because they all get multiplied to each other. So over on the side, I would tell what they are. Length is going to be what? What do y'all want it to be? 5. What's the width going to be? 3. And the height? 4. Where are you getting 7 at? Okay, I was just a little curious. Everybody say 5, 3, and 4, right? Now I'm going to go, after I copy my formula for this time, I'm going to substitute in. What did you tell me L was? 5 centimeters. And what was W? 3 centimeters. Plus 2. And what's my width? Width. My W. 3. And height was 4. Y'all see where I'm getting those after I labeled them? And I like labeling them because if I start doing half the problem, go do something, answer a phone call, play a game, go outside, eat supper, do something, come back, I'm not having to try and figure out. I already know what my L, W, and H is. I already know what I've used. Plus, now I'm going to do this one. 2 times, what's L? And what's H? Yep. You're going to multiply those, but then you add, okay, the product of all those together. So, order of operations says let's multiply these first. So what's 2 times 5 and 10 times 3? So this is 30 what? How many centimeters did I multiply? 2, so that's centimeters square. Because what am I finding? Surface what? Surface area, and area is always a square, right? Okay. This one, 2 times 3, 6 times 4, 24 centimeters squared. 2 times 5, 10 times 4 centimeters squared. Now I'm going to add them. So in my head, to go quickly, 30 and 40 is, and 70 and 24 is, so 94 centimeters squared is how much material, whatever I want to cover it with, is going to be needed to cover that rectangle box that I had up there. Now, it's not going to overlap anything. Okay? So, that would be exact. If I was to take it and cut it and paste it and glue it on each side of the box, that's how much material, whatever it was, whether it's wrapping paper, cloth, trash bags, whatever, that I would need to cover that box. Well, Yes. If somebody is spraying this basket, okay, and you need to look at how much spray paint I need, or paint with a paintbrush. Yes. Okay. So that can be used. Now, if we talk about wrapping paper, what did we talk about a minute ago? We overlap. So am I going to need more or less if I overlap? More. Because what happens when you overlap? I already have material here and I put more material on top of it, right? So when we wrap presents, we need more than what we actually need. Okay? But if we're talking about something like painting the whole surface area of this box, okay, then I could get exact. Yes, but typically what you're thinking of as a roof, okay, it's not three-dimensional though. Okay, you see my point? But you're still using what formula there? You're using an area, correct? Now, we have to kind of think too, okay, depends on what material you're using. If you're using tin, which is what a lot of people, metal, we don't overlap it. But what happens when we use shingles? Shingles actually overlap because they put a piece of shingle on the roof and then the next piece comes up and it overlaps it. And then the next piece overlaps this one and overlaps and overlaps. So, but builders have figured that out. So they've used, if you use the correct measurement to lay your shingles, they're going to help you out by putting that on the back. Okay? Shingles is a disease. Okay? There's two different shingles. Shingles for a roof, okay, that people put on top of their house so their house doesn't leak. Okay? And then there's the shingle virus, which is a chickenpox virus. Okay? So if you ever had chickenpox, okay, you may can get shingles. My understanding too is if you've had the chickenpox shot, you can also get the shingles. Now I think, okay, and I will tell you, if you ever get shingles, the virus, I've understood it's very painful. And shingles, I know we're doing a health lesson really quickly. Shingles run along a nerve in your body. So a lot of people will get it on their torso, okay? And unfortunately, women, sorry about this, most of the time it's right where your bras rub. I mean, sorry, I hate to say it, but usually it's across your back or your chest. Okay, I've seen a lot on your face. And why do you think that is? But those nerves are more apt and they're closer to the surface, especially on your face. Your nerves, there's not a lot of tissue to cover. Okay, think of your back. Okay, you've got a lot of your bones that you can kind of see on your back versus your thigh. There's a lot more tissue there. So your nerves are more inside. Okay? All right, back to math. So if it's not a math question, don't ask. All right, what? Just standard unit. No. No. A cubic tells me I have a three-dimensional figure, like the rectangular box. Square tells me it's a flat surface. Okay, I have no height to it. Okay, and just a standard would be me just measuring a piece of string, how long something was. Okay, so I'm looking at three different dimensions if I do volume. Do what? That's okay. I don't care. Okay. It'll be on YouTube. All right, anybody have a question on surface area of rectangle?